Question number 74. At a car museum, you see a Mustang that is 15 feet long and 5.5 feet tall. Let's go ahead and label our drawing right now, because we know those measurements. We've got 15 feet for the length of our car, and we have a height of 5.5 feet. So our height is 5.5 feet. I'm just using the abbreviation for feet here. It looks like a prime notation or an exponent of 1, but in this case it represents the unit of measure, which is feet. And then it says you decide to build a scale model of the Mustang at home. If you want the model to be 18 inches long, how tall would you have to build it in order to keep the length and height proportional to the original car? Well, proportional means we are doing a dilation. We're going to shrink the car down so we know the height and the length are proportional to the height and length of the actual car. So the question tells us that the length of our model car is going to be 18 inches, and the height of our car is what we don't know. We're going to label that with a variable of x. So let's set up our proportion. Now, many of you are making mistakes on this, so I want to go over how we're going to do this. Let's match up corresponding sides of the two cars, just like you would match up corresponding sides of two triangles. The 15 feet, or the length of this car, corresponds to the length of the model. So our first ratio is going to be 15 feet over 18 inches. Now that's going to be equal to the ratio of the heights. But in this case, class, you need to make sure you write this ratio the correct way. And the way you have to remember this is, if the 15 feet on the top of this ratio came from the actual car, then the measure on the second ratio of this proportion has to actually come from the length of the actual car. I'm sorry, the measure of the actual car. So 15 feet came from the actual car. That means we have to write the height here from the actual car, which is 5.5 feet. The bottom of this proportion is going to be the measures from the model car. So that means if 18 inches came from the model car, then the height needs to come from the model car in the denominator, and that's going to be the value of x. Some of you are flipping this around. You're writing 15 feet over 18 inches is equal to x over 5.5 feet. Your problem is you flipped the fraction around. You combined, or you put actual measure on the top of this ratio, and then model measure on the top of this ratio, and that will give you a wrong answer. So set it up correctly. Make sure you have actual measures on top, model measures on bottom, or you could actually put the model measures on top and the actual measures on bottom. What you don't want to do is flip them around. Now I'm going to run out of time on this video, so I got to get this done very quickly. Let's cross multiply. We've got 15 feet times x is equal to 5.5 feet times 18 inches. Well, we have feet on both sides of this equation, so I can actually cancel the feet. I can cancel the feet. So this is going to be 15x is equal to 5.5 times 18 inches, and that's going to be 99 inches. We can go ahead now and divide both sides by 15, and we end up with, let's go ahead and show you that, divide both sides by 15. The 15 cancels on the left side because that turns to 1, and x is going to be equal to 99 inches divided by 15, which is 6.6 inches. So the height of our model car is going to be 6.6 inches, and that allows us to create a model that is proportional to our actual car.